This problem would like us to write an expression for the apparent nth term. Okay, so as I look at this one, I can see that a sub n, let's see, it's moving up by 3 every time. So that corresponds to like a slope of 3 on a line. So I'm going to start off with a 3n. And if I were to replace n with 1, I would get the number 3, but I wish it were a 1. So instead of doing a 3, I'm going to subtract 2 from that. Now, this is the right answer, but let's just check it to make sure. The second term would be 3 times 2, which is 6. 6 minus 2 is 4. 3 times 3 is 9. Minus 2 is 7. This works. Okay, this one, little bit more in depth, right? This one, you can see a pattern on the top that's going, let's see, 1 over 2, 2 over 3, 3 over 4, up, 5 over 6. I meant to put a 4 over 5 there, so I'll have to change that on the key. 4 over 5, 5 over 6. So that pattern, on the top, you can see that it's going up, and there's our counting numbers, essentially. 1, 2, 3, 4, 5. So a sub n in the numerator, I'm just going to put an n, because that's going to count 1, 2, 3, 4, 5. In the bottom, we want it to be 2, 3, 4, 5, 6. In other words, one more than what's in the numerator. So in the bottom, I'll put n plus 1. So notice now, a sub 1 is 1 over 1 plus 1, which is 1 over 2. A sub 2 is 2 over 2 plus 1, which is 2 over 3. And this pattern seems to be working, with my correction. Next to, write an expression for the apparent nth term here. Okay, so for this one, first of all, I see that it's alternating between a positive and a negative, right? Positive, negative, positive, negative. So the first thing I'm going to do is put in what I call my alternator. I'm going to put a negative 1 in there, and I either want it to be to the nth power or the n plus 1th power. The way I tell is that if I were going to put an n here, then the first term would have negative 1 to the 1, which would be negative, but I wish for it to be positive. So that's what determines I wish for negative 1 to be to the power of n plus 1. That's going to take care of the plus minus plus minus. In the numerator, I see 1, 2, 4, 8. Those are powers of 2. So I'm going to put 2, and I'm going to have to put a power up here. And notice that if I were to put a 1, I would get the second term, and if I were to put a 2, I'd get the third term. So in general, I actually want it to be 1 less. So as my exponent, I'm going to give it a shot as n minus 1. And in the denominator, I'm seeing powers of 3. 3 to the first, 3 squared, 3 cubed. So down there, I'm going to put a 3. And again, I want that one to be my first term, so I'm going to put an n. This seems to be the answer. Let's check it. If I were to replace n with 1, we would get 1 plus 1 is 2. Negative 1 squared is positive. That's good. 1 minus 1 is 0. 2 to the 0 is 1. I'm happy. And n equals 1 gives me 3 to the first power. This seems to be working. For the last problem here, I tried to set it up in a really intentional way so you can see where your counter is happening. See, there's the 1s, there's the 2s, there's the 3s. So the setup for this problem was supposed to be a sub n equals n plus 1 over n plus 1. So if you can see where that counter is occurring, the thing that's actually counting the first term, second term, third term, then that can lead you into a short way of being able to figure out what your apparent nth term is.